Okay, this is going to be the Unit 8, and we're going to talk about the ratio test today. So the ratio test is a test for convergence, so we're trying to see if a series, if a summation converges or diverges. And just the conditions, just like we've been working with this unit, we have a series of non-zero terms. We're trying to add up all those terms. So if you look at what the ratio test says here, it says that the summation is going to converge if this is less than 1, and it's going to diverge if that's greater than 1. Well, then, of course, we need to know what happens if that equals 1, and that means it'll be inconclusive. Okay, so you'd have to use something else. So here, what really is that big old chunk? So we're taking the limit as n approaches infinity, and really I want you to read that numerator as the next term, okay, divided by the original, okay? So basically what this means is wherever we see an n, we're going to replace it with an n plus 1 divided by the original, and then we'll use some algebra there and we'll kind of clean them up. So the idea here is how am I going to know to use it? Well, the ratio test is especially useful if you see factorial. So if you see those exclamation points hanging out, that's a clue that the ratio test would probably be a pretty good strategy. Okay? So we'll kind of start with an example, first one where it works. Okay? So determine whether the series converges or diverges, state which test we used. Okay, so we're going to start out here with 2 to the n over n factorial. Again, a good idea for a ratio test is when you see that factorial, so that's kind of my clue that I might want to use it there. Okay, so I'm going to kind of start out and we're going to take the limit as n approaches infinity, and don't write too big here. So I'm going to say I'm going to take the limit as n approaches infinity, and then we have to do the original function divide over, right? Or the original function plus 1 divided by the original. So it's going to be, and notice there were some absolute value bars there. So I'm going to say the limit as n approaches infinity. I'm going to leave myself some space up there, and then it's divided by the original. So I'm going to write in the original one there, n factorial. That part's good, and I got my absolute value bar. And then the numerator was that a sub n plus 1. So wherever you see an n, you just write n plus 1. So wherever you see an n, you put n plus 1 in parentheses, of course. So we've got this, and this immediately looks uglier than what we started. From here, though, we're just going to use some algebra, so you can call it that, most of you call it keep, change, flip. So we're going to still take the limit along with us, but we're going to say that's the limit. And since we're dealing with all positive numbers here, I don't need to worry about that absolute value. But we're going to say we're going to keep this. It'll be 2 to the n plus 1 over n plus 1 factorial. And then we're going to change to multiplication, and we'll flip that so we get n factorial over 2 to the n. Okay? Okay, so this might not look much better, but if you recall from, I think it was day 1, when we actually talked about those properties of factorials, we can actually use this to our advantage to kind of cancel things out. So, for example, if we had, if you have anything of the same base raised to an exponent, so like if you had x to the 5th divided by x to the 3rd, you would tell me that that's the same thing as keep the base and you subtract the exponents, right? So I'm going to apply that same thing to this. I have the same base, so it's 2's, so what you need to do is subtract the exponents. So really you're saying that's going to be, so 2 to the n plus 1 divided by 2 to the n. That's actually equivalent to 2, and then it'll be n plus 1 minus n. Well, that n takes out that n, so I'm left with 2 to the first power, which is just 2, right? So that equals 2 to the first, which is 2. So there's kind of my side work for that. So I know that that's going to kind of take that out. And then what am I going to do with these guys here? Well, remember a factorial, right? So n factorial is really n times n minus 1 times n minus 2, right? Dot, 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 until you get to times 2 times 1. Well, what does that mean that n plus 1 factorial is? Well, it's n plus 1, and then 1 less than that would be n. 1 less than that would be n minus 1, and so on and so forth, till you get to times 2 times 1. So if you kind of think of it this way, right, Well, this would take out this, right? Everything, as soon as you get something to match, the rest of it cancels. So this will take out everything except for the n plus 1. So when I go to clean this up, I'm going to clean this up and rewrite it. I still didn't take the limit, so the limit comes down. So I've got the limit as n approaches infinity. This took this out to be just a 2 to the first power 2. Okay? Then I've got, in my denominator, this n factorial took out everything from the n plus 1 factorial except for that n plus 1. This is something that is now much easier to deal with. So now I'm actually going to take my limit. You can use your horizontal asymptote rules here. Right? This is bigger on the bottom, so it's going to 0. Or you can kind of plug in infinity there, so you get 2 over infinity, which goes to 0. So either way, by horizontal asymptote rules or by kind of plugging in infinity there, you get that that's 0. But then you need to kind of remember, like, wait, what am I doing? Well, you need to kind of go back up and say, all right, what was I doing? I took the limits, right, as we approached it, and 0 is less than 1. So I can conclude that it converges. So 0 less than 1, therefore, converges by ratio test. Okay, so you've got that one. All right, so then we will take a look at example B here. So again, a big clue that the ratio test might be a good strategy is because I see that factorial. That's kind of my clue that ratio test will work. So I take the limit as n approaches infinity. And then some of you will get good. You're going to kind of skip this step here and you're going to go right to this step to kind of save yourself some paper. But basically you take the original, but you add 1 wherever you see an n. So if you replace this n with an n plus 1, you get n plus 1 plus 1. Well, that's 2, right? So you have the limit of n plus 2 factorial now, divided by 3 to the n plus 1. So there's the step where I'm replacing all the n's with n plus 1. Normally I divide by the original, but I'm going to save some paper and say I'm going to multiply by the reciprocal of this. So that'll be this, and then an n plus 1 factorial there. Okay. So again, we're going to kind of use that same skill there with those factorials taking each other out and kind of canceling down to kind of clean this up. Okay? I didn't take the limit yet, so the limit just gets rewritten. Okay? So you've got, again, same bases. You subtract the exponents. Now be careful this time, though, because now it's n minus the quantity n plus 1. Okay? So think about what that is. It's n minus n plus 1. So you have to distribute that negative, so you get n minus 1. Okay? So if you kept it up here, you're going to have 3 to the negative 1 power. Or you could just say it's 3 to the first power in the denominator. So it just depends how you kind of want to work that. I'm going to say it's going to be a 3 in the denominator. Okay? And then these two. Again, if I was writing this out, it'd be n plus 2 times the quantity n plus 1 times the quantity n times the quantity n minus 1, and so on until I got to times 2 times 1, because that's what a factorial is, right? 4 factorial is 4 times 3 times 2 times 1. So as soon as you get it to match, then it takes it out. So this one's bigger. So this one takes out all of that one, and all that I'm left with is n plus 2. Again, this limit is much easier to deal with than, this complicated thing up there. So here, when you plug in infinity, you get infinity. Again, you could do that by your horizontal asymptote rule here. It's bigger in the top, so that means you're headed towards positive or negative infinity. Here, obviously, we're headed towards positive. Okay. So what can you tell me about infinity, right? You have to kind of remind yourself, like, what am I doing? I'm doing the ratio test. So infinity is definitely bigger than 1. Okay. So if infinity is greater than 1, then I can say that this diverges by the ratio test. Okay, so there's an example of one that converges and one that diverges. Okay, and then on the second page there's a couple more examples. I'd encourage you to kind of pause the video, see if you can get the next one started, and then I'll go back and walk you through the next one. Okay, so hopefully you've had a minute there to kind of work through. Again, the idea that I see this factorial tells me that the ratio test is a good one to use. So, I use the ratio test there, and I'm going to do that keep, change, flip, okay? So, once you have that limit, after you kind of plug in that n plus 1 wherever you see an n, then you do your keep, change, flip, and you kind of take it out, you're going to get something that cleans up a lot nicer than, you know, that original mess. So you should get that one diverged by ratio test, okay? And then the next one, we're going to see when you replace it, it gets a little bit messier. Let me see if I can move that up. I'm having some recording issues. Okay, let's see. So you've got this, again, you see this factorial. It says that ratio test is good, so we take the limit as n approaches infinity. Wherever you see an n, you have to plug in an n plus 1. So be careful here, because you're actually going to have to distribute this 2 across, okay, both of there. And then here, when you replace this with an n plus 1, it's going to be that quantity square. So you replace all your n's with n plus 1, and then divide it by the original, or multiply by the reciprocal of the original, so you've got that. This one may take a few more lines of work for you to kind of wiggle out of there, but you're going to hope that you can kind of cancel some of this. So I went ahead and distributed this 2 across, so it became 2n plus 1. That helps you kind of see when you expand that out as a factorial, it becomes 2n plus 1, then subtract 1 from that gives you 2n, subtract 1 from that. You're going to get to here, okay? So you might need to kind of expand that out quite a bit. And you're like, it's not going to match this top one, right? So you'd start expanding this one out, and you're like, all right, one less than that. And you see that these are the two that are going to match, okay? So this, right, gets taken out with that. And then here, okay, be careful, you cannot cancel those. So they both just get rewritten. So you have this in your numerator, then in your denominator you have that 2n plus 1 and the 2n, and then you still have this n squared from over there. So you get to here, and now it's probably worth your time here to kind of clean this up. So via some algebra, clean that up. I went ahead and distributed the 2n, then I multiplied by the n squared, so you end up with this 4n to the 4th plus 2n cubed there. Okay, so once you get there, then you're like, all right, what can I do? I'm going to take the limit. Well, the degree in the numerator is 4. Okay, the degree here is there. So you can kind of compare it that way and do your HA rules. You can do it that way because even if you expanded this out, it'd be an n squared. Okay, here you got an n to the 4th, so this is big booty bottom, drop shoot is 0. Or you could L'Hopital it a bunch of times. Like if you tried the plugging in infinity bit, you'd end up having to L'Hopital this several times. So in this case, it's actually easier just to use your HA rules from the beginning. So once you get to there, you get that this is going to end up being 0, right? So you could say this equals 0 by HA rules, or you could keep L'Hopitaling. But again, once that equals 0, we know that 0 is less than 1, so this thing's going to converge by ratio test. Okay? So hopefully that gives you kind of an idea of the ratio test there. I said I'd try to make a video that was 15 minutes. So, all right, have a great weekend, and we will see you when you get back.